Hello everyone, and welcome to StreamFab's channel. Today we are going to discuss an interesting topic in the digital age. Why some videos can only be played but not saved. Why downloaded videos can only be played with specific software. When browsing websites like Netflix, we often feel confused about such things. Videos downloaded on mobile phones can't be viewed before they are even watched. You can't download the videos you want through computer, even though you have already paid for them. Actually, this is all due to DRM. Digital rights management is a technology used to protect digital content, which restricts users' use and dissemination of specific content. The purpose of DRM technology is to protect intellectual property while preventing illegal copying and piracy. However, opponents argue that it stifles innovation, infringes on users' legitimate rights and interests, and hinders the growth of the digital economy. How do they work? DRM is essentially an encryption technology, so let's first look at the working principle of encrypted videos. Content providers package videos through packagers, such as FFmpeg, Shaka, MP4Box, Bento4, etc., generating slice files and index files, which are then uploaded to a CDN server. The user's player parses the index file to load the corresponding slice files for playback. This is the general workflow of video streaming, but the simple model is like being naked. So many websites encrypt their videos. If only a single key is used for encryption, then users can obtain both the encrypted video and the key at the same time. This is like putting a lock on your door and then placing the key in a flower pot by the entrance. It's not entirely useless, but it's barely better than nothing. Therefore, a key server is usually added, a paired ID is generated for the key, and the corresponding relationship is stored on the server. Then the key ID is sent to the user, and the user needs to use this ID to exchange for the key from the server. This way, the key is not directly exposed to the user, and further identity verification can be performed during the exchange phase. However, this is only a partial solution, because in the end, the key still has to be delivered to the user. In browsers, no matter how complex the encryption method is, as long as the decryption logic is executed within the web page, it can be analyzed and cracked. Therefore, another technical solution needs to be introduced: DRM. DRM is actually a comprehensive solution for protecting digital content, with encryption being just one of its technologies, along with others such as digital watermarking. It doesn't only protect video content, but also other types of digital content. For encryption, it similarly uses a key exchange scheme. Currently, the mainstream DRM encryption technologies include Google Widevine, Apple FairPlay, Microsoft PlayReady. These service providers either have their own systems or are developers of mainstream browsers. They can embed an additional content decryption module (CDM) within their ecosystems. By obfuscating and hard-coding the decryption logic into this module, it becomes much harder to crack. They can even collaborate with hardware manufacturers to execute the decryption process within the hardware itself. This is known as TEE, Trusted Execution Environment. Unless there's a significant vulnerability in the hardware itself, it's virtually impossible to crack. DRM, CDM, and TE form a complete chain of protection, where software-based decryption and hardware-based decryption each represent different stages within the overall DRM service framework. Having understood these concepts, we can now examine how they function. First, they generate a key pair based on the user's hardware information. The CDM holds the public key while the private key is stored in the hardware. As long as the hardware remains uncracked, the private key is absolutely secure. Previously, the EME only needed to send the key ID to the server to exchange for the decryption key, but this is no longer the case. Now, the EME first needs to send the key ID to the CDM. The CDM will generate and return a challenge containing the public key. The EME then forwards this request to the licensed server. After receiving the request, the server exchanges the decryption key using the key ID, then encrypts the decryption key with the public key. and generates and returns a license that can only be opened with a private key. After the EME receives the license returned by the server, we send it to the CDM, which then transparently transmits it to the TEE. The TEE uses the private key to decrypt the license to obtain the decryption key inside, and finally, uses the decryption key to decrypt the video file. This process might sound complicated at first, so feel free to revisit it a few times. In simple terms, think of it like ordering a valuable item online. The seller sends you a password-locked package using a special shipping label. The password to unlock it isn't created until the package arrives at your doorstep. At that moment, your home vault automatically generates the password, ensuring that even if the package is intercepted, no one else can open it. Certainly, this flowchart simplifies many details, but the core principle is as described. Therefore, the videos you get from Netflix are essentially encrypted, and only Netflix's official app can decrypt and play them. The decryption key is temporary. Netflix's servers control the key's validity period, and once it expires, the key becomes invalid and the video can no longer be played. You might think of another method, screen recording. This is indeed a viable solution, but you're not the only one who's thought of it. In fact, Netflix and other video platforms have considered this as well. Therefore, for some video sites, when you attempt to permanently save videos through screen recording, they employ technical measures to display the entire video content as a black screen. We'll explain the reasons for this in our next video. This method of permanently saving videos through recording is what we call re-encode. Of course, this is our own term, and not a professional designation. Due to its relatively low technical requirements, many software currently uses this method to meet user needs. Even though many software claim to offer original video, they essentially still save videos through recording. So how can you distinguish between these two methods? When operating in recording mode, there's invariably a video encoding/decoding process. That's why we call it re-encode model. This encoding-decoding process typically demands substantial system resources, particularly memory and GPU capacity. So open the task manager and observe. If download something directly, the software will consume minimal CPU or GPU resources, typically less than 20%. In recording mode, the software exhibits significantly higher resource consumption, typically greater than 30%. Additionally, the re-encode mode has several more drawbacks. The output video and audio quality is inferior. It does not support HDR or Dolby Vision. The video acquisition speed is slow, etc. If your computer lacks a dedicated graphics card and cannot perform hardware acceleration, saving a 2-hour movie in re-encode mode could take as long as 2 hours. So is there a better way to get what you want? Absolutely. That's where StreamFab comes in. With direct download mode, you can save videos faster and have more choices. Compared to re-encode mode, direct download preserves superior video-audio quality and supports HDR Dolby Vision. If your internet speed is fast enough, you could download a 2-hour movie in just 10 to 15 minutes. Join StreamFab today. StreamFab today, save for tomorrow. Thank you for watching this video. If you find our videos helpful, please subscribe to our channel and like us. We'll share more interesting video knowledge with you.